All right, welcome to lesson 3. This is a lesson on finding the greatest common factor of a monomial. So we have looked at finding the greatest common factor of a number. Now we want to look at finding the greatest common factor of an algebraic term. So we're going to do it the same way. We're going to create factor trees. So let's look first at 15x squared y squared and 12xy to the cubed. So if I take 15x squared y squared, do the number the same way that you have. So that's going to become 3 and 5. And then what we do is we just expand out the exponent part. So do your number kind of all the way down to the bottom and then take your letters. So x squared means x, and y squared means y and y. So that's my factor tree for 15x squared y squared. And if I have 12xy cubed, this is 4 times 3, which is 2 times 2. So this becomes 2 times 2 times 3. And then if I expand out my letters, I have x and y, y, y. And then I do it the same way. What's common to both of them? So 3 and x and 2 y's. So my GCF of these two terms is 3xy squared when I look at what's common there, okay? Let's take a look at another one, a little bit bigger. So 120x squared y squared, or x squared y cubed z. So basically, we're just going to do kind of a little factor tree for 120 first. So 120 is 10 and 12. This is 2 and 5. This is 3 and 4. That breaks to 2 and 2. So 120 x squared y cubed becomes 3 2's and a 3 and a 5. And then when I expand out my letters, I have x, x, y, 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 and a z. And let's do the same thing. So for 200, I have 20 times 10, 4 times 5, 2 times 5, 2 times 2. So this guy becomes 2 times 2 times 2 times 5 times 5 times x times, I'm running out of space, y times z, 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 z. Okay, so what's common to them? Well, I've got 3 2's in common. I've got a 5. I've got 1x. I've got 2 y's and 1 z. So my greatest common factor is 2 times 2 times 2, which is 8. 8 times 5 is 40. So 40 x, y squared, z. Now, if we look at the variable piece of our GCF, okay, so look only at the variable part of it, and then look at the original. So if I look at this xy squared and then look over here, what you should notice is that if you look at the x first, you'll see an x there, and y squared, y squared. Over here I have x, y squared, z. Looking up here, x, y squared, z. What you should notice is that we take the lowest exponent of each letter. Okay, so when we're taking the variables out, we can just look at the lowest of each letter. Eventually, we want to move away from having to draw a factor tree. So let's think about this first. And if you need help with your times tables, I've got timetable charts for you, but we want to know what goes into both 10 and 12. So 2 does. I don't think we can go any higher, so we can take out a 2. And then we want to take the lowest of our letters, right? So the lowest is a single f and a g cubed. Okay, let's look at this next example. 18 x to the 6, 8x to the 8, y to the 6, 9 x cubed y to the 6, and 12 x squared y to the 5th. So looking at my numbers, 18, 9, and 12. So I know that 3 can go into all of those. I'm going to take a 3 out. I look at my letters. I've got x to the 8, x to the 3, x to the 2. So I can take an x to the 2 because it's got to be able to come out of all of them. And my letters, y to the 5. Okay, so that is finding the greatest common factor. So you can go ahead and work on the practice questions now.